Welcome, everyone, and a special welcome to you, the listener joining us today. We are really thrilled to have you here for this deep dive.
Yeah, thanks for having me. It's a great topic today.
It really is. Today, our mission is to decode a pretty massive and highly sophisticated shift in the cybersecurity landscape. We are working from an article published on February 26th, 2026 by Rhino Cybersecurity.
Right, the piece by Diego McEstrelin.
Exactly, Diego McCasterlin. And the title is Hackers Use Fake Job Interviews to Hijack Developer Computers. Our goal today is to really pull this apart, analyze the specific vectors these threat actors are using, and look at the broader implications for the tech industry.
Because it affects basically everyone touching code right now.
Totally. Okay, let's unpack this. Hackers are actively weaponizing the tech industry's hiring pipeline. They are taking the standard super high-pressure process of a technical assessment and using it as a Trojan horse.
Which is brilliant in a very dark way.
It is. They use fake test projects disguised as standard take-home coding assignments to infiltrate developers' local environments.
The brilliance of this approach really lies in its exploitation of expected behavior. I mean, this isn't some spray-and-pray phishing campaign where they just hope you carelessly click a shady PDF.
Right, like an email saying you want a gift card.
Exactly.
Yeah.
This is a masterclass in social engineering targeted directly at a developer's daily workflow. Think about it. When a developer sits down for a technical assessment, their mindset is totally focused on problem solving.
Yeah, they want to impress the potential employer.
Right. They're expected to clone a repository, install dependencies, and spin up a local server. The attackers are simply hiding their payload within those exact standard necessary actions.
Because your guard is completely down.
Yes. The context dictates that downloading and running this specific code is the mandatory first step to getting the job. So the victim is blind to the suspicious behavior.
That context switch is the vulnerability. If you are auditing some random open source project, you might have your guard up. But when you think you are talking to a legitimate hiring manager for a lucrative role, your default stance is just compliance.
You just follow the instructions in the readm file.
Exactly. And we should note, these campaigns are incredibly well-resourced. According to the article, threat intelligence from major players like Microsoft has traced these operations back to highly organized groups with ties to North Korea.
Which tells you a lot about the endgame here. These state-backed advanced persistent threats, or APTs, are targeting the tech sector for a couple of reasons.
It's not just kids messing around.
Not at all. They want proprietary corporate secret source code and passwords. But they are also actively hunting for cryptocurrency wallets. By targeting developers during the hiring phase, they go after the exact people who hold the keys to the kingdom.
Bypassing the corporate firewall entirely.
Right. They just go straight for the developer's lightly managed personal laptop.
It makes complete strategic sense. I mean, why spend months trying to hack a corporate network when you can just trick a senior DevOps engineer into running your malware under the guise of a coding test?
It's the path of least resistance.
It really is. And the article outlines 3 specific, sneaky technical traps these groups use. And these are in the wild right now. Let's break these down. Starting with method 1, which the article calls the trust trap. This involves Visual Studio Code.
Which is ubiquitous. Almost everyone uses VS Code.
Right. So how are they weaponizing a text editor?
So we need to look at the workspace trust feature in VS Code. It was actually introduced as a security measure to prevent arbitrary code execution.
Oh, the irony.
Yeah, it really is. It prompts the user to confirm whether they trust the authors of a newly opened folder. If you don't grant trust, it disables certain tasks. But the attackers use the interview context to bypass this.
Because the candidate thinks they need to trust it to do the assessment.
Exactly. The candidate clones the repo, opens the directory, and sees the trust prompt. Because they believe this is a legitimate test from an employer, clicking trust is just a reflex.
It's like a vampire, right? They can't come in unless you invite them across the threshold.
That is a perfect analogy.
Yeah.
And the moment they click that button, they trigger the trap.
But how does clicking trust actually run the malware?
It leverages native configuration files, specifically the .csco directory. Attackers configure files like tasks.json to include malicious pre-launch tasks.
So just trusting the workspace gives it permission to run those hidden tasks.
Yes. The editor automatically executes a background shell script. It reaches out to the internet, downloads malicious code, and runs it. All while the developer just sees their editor functioning normally.
Just single click. No complex hacking required.
Just one click, and they are in.
That is wild. But let's say a developer is super cautious. Maybe they inspect that .vscode folder or they use a totally different editor. The attackers have a second method. The article calls this the in-memory phantom.
If we connect this to the bigger picture, this second method exploits how modern web development actually works.
The build process.
Right. A developer is going to run commands like npm run dev to see their work. The attackers anticipate this. They construct the fake project with a package.json file loaded with dependencies.
But they sneak in some poison pills.
Exactly. Mixed in with legitimate packages are counterfeit libraries. They hide malware inside fake versions of common trusted libraries like jQuery.
And this is where the execution gets incredibly devious. When the developer starts their local server, it fetches these libraries.
But the crucial aha moment here is that the payload isn't saved to the hard drive. It fetches a hidden payload and runs it directly in the system's memory, in the RAM.
Which makes it invisible.
It is terrifying because there is no physical evil file sitting on the disk. Traditional antivirus software relies on scanning the hard drive for known bad files.
So the antivirus never triggers a warning.
Never. It's like the difference between writing down a secret plan on a piece of paper versus just keeping it as a thought in your head. The antivirus is looking for the paper.
But the thought is already executing the plan.
Precisely. It blends in perfectly with the normal background noise of a developer compiling code.
An invisible phantom running alongside your local host. Unbelievable. Which leads us to the third trick. Method 3 is the backend heist. Once the malware is running in memory, it needs to find something valuable.
Yes, and it targets environment variables.
The .n files.
Right. Developers handle highly sensitive information like API keys, database passwords, and cloud tokens by storing them in environment variables. It's the digital vault.
It's standard practice to keep them out of the main source code.
Exactly. The attackers know this. So once the fileless malware is running, it immediately scans that digital vault. It steals the API keys and passwords, sends them back to the hackers, and then receives new commands to execute.
So it's a two-way street. It exfiltrates your secrets and then turns your machine into a remote-controlled drone.
It establishes a persistent foothold.
Okay, here's where it gets really interesting. Because we aren't just talking about a couple of hackers in a basement writing clever scripts.
No, the scale is massive.
The host data from GitLab and other platforms shows this operates like a professional corporation. It's a global hacker enterprise.
The infrastructure required to pull this off requires corporate-level efficiency. They generate hundreds of synthetic identities to get through HR screenings.
Fake resumes, fake GitHub commit histories.
And they use AI to generate incredibly convincing stolen or generated photos for their profiles. They build realistic personas that can easily pass an initial recruiter call.
And the financials are staggering. The Rhino cybersecurity article shared a mind-blowing stat. Some of these fake IT workers have reportedly earned over $1.6 million.
It's incredible.
Just by landing temporary contract jobs or stealing directly from the companies interviewing them.
They get hired, they get shipped a corporate laptop, they integrate into the daily stand-ups, and they collect a legitimate salary while quietly stealing source code or deploying ransomware.
So they're officially recognized employees, which means their network traffic is trusted by the corporate firewall.
Yes. And that brings up how they hide in plain sight. Even the malware on the compromised developer machines has to phone home right.
Right, it has to send the stolen passwords back to the attackers. But wouldn't a firewall block traffic going to some random shady website?
Normally, yes. But they use a technique called living off the land. Instead of using shady web addresses, they store their malicious instructions on completely legitimate, trusted services.
Like GitHub.
GitHub gists, Google Drive, and even blockchain technology.
Wait, blockchain, like NFTs.
Yeah, exactly. They can hide malicious instructions inside an NFT or a simple text file hosted on a decentralized network. Because sites like GitHub or Google Drive are inherently trusted by companies, their phone home signals look like completely normal web traffic.
Like a developer just downloading a library or reading a shared doc.
Exactly. A company firewall would never dream of blocking GitHub. It would cripple the engineering team. So they smuggle their commands right past the digital perimeter.
It's like hiding a stolen diamond inside a jewelry store. It just blends right in.
Perfectly camouflaged.
So what does this all mean? We are looking at a landscape where the initial attack vector is a normal job interview. The malware is invisible in the RAM, and the network traffic is camouflaged as Google Drive.
It means compromising the laptop is just step one.
The beachhead.
Right. The real goal is getting that foothold inside a company's network so they can move laterally.
Moving from the laptop to the server.
Yes. They hunt for customer data source code or financial accounts. Developers possess the keys to the kingdom. Once the attackers hijack that session, they pivot and escalate their privileges.
So how on earth do companies defend against this? The article by Diego Macastrolin outlines some pretty strict defensive measures, starting with the developers themselves.
Developers must absolutely never click trust on a project in their code editor without manually inspecting the configuration files first.
You have to look at the .vscode folder and the package.json scripts.
You have to assume it's hostile until proven otherwise.
But relying on individual vigilance is tough. Humans make mistakes, especially when they are stressed during an interview.
Which is why the article recommends a complete overhaul of how companies hire. The traditional take-home assessment where you just download code and run it locally is dead.
It's too risky. So what's the alternative?
Companies need to use isolated sandbox environments for all technical tests.
Like a dedicated virtual machine in the browser.
Exactly. So if malicious code executes, it is trapped inside that sandbox. It cannot touch the developer's actual hard drive or the corporate network.
And when the interview is over, you just delete the sandbox.
You destroy it and the malware goes with it.
That makes total sense. It's essentially an air-gapped approach to hiring. The article also issues a pretty stark warning about the future of the industry. It calls it as a sort of natural selection.
It is. As these hackers become incredibly skilled at crafting believable personas and passing interviews, only the most prepared and skeptical developers will survive this digital trap.
You have to treat every technical test like a potential cyber attack, which is just a crazy way to have to look for a job.
This raises an important question, something I think you, the listener, should really mull over after we wrap up here.
Let's hear it.
If hackers are now perfectly mimicking the behaviors, the resumes, and even the code of legitimate developers, how will companies in the future distinguish between a brilliant new hire and a highly sophisticated digital infiltrator?
Especially when the very act of evaluating them is the trap itself.
Exactly. The simulation is becoming indistinguishable from reality.
That is a deeply unsettling thought. We've covered so much ground today. From weaponized job interviews and the VS Code trust trap to invisible in-memory malware and million-dollar hacker corporations hiding inside NFTs.
It is a radically shifting landscape.
It really is. Thank you so much to you, the listener, for joining us on this deep dive. We hope it gave you some critical insights into securing your workflow. Until next time, stay curious and above all, stay skeptical.